Okay, so I'm going to try to explain from Calculus 1 all the way to Calculus 3 in like 5 minutes. So to start with Calculus 1, if you have, here's just a basic graph, and here you have a line it's going to go 1 to the right and 1 up. So you have a change in x is equal to 1, and a change in y is equal to 2, or is equal to 1. So for every, so the change in y with respect to x is equal to 1. So that's what we say. Change in y with respect to x is equal to 1. So if you multiply this dx onto the other side, what you have is dy is equal to 1 dx. And if you apply an integral, what you will get is y is equal to x, which is the line that you see up here. Okay, so if you have the change in x was equal to 2, right, you'd have something like this, where you have every one y. So if you have y equals 1, you have x equals 2. Right, so you have y equals x over 2. So when y, if this side is 1, x must be equal to 2. So you have dy dx is equal to 1/2, where you have change in y divided by change in x. So change in y is 1, change in x is 2, change in y over change in x is 1 over 2. So you have dy is equal to 1 over 2 dx, and you apply an integral, you have y equals x over 2, and when you say x equals 2, y equals 1. Right, so that kind of proves, so what the formula for this is if you look at this, is if you want to know if you have y equals 2x, to go from dy to y is the same as y to dy. So you're doing a derivative is the opposite of an integral. So y to dy, so you say you want to do a derivative of both sides, what you get is dy is equal to 2 dx. Because you do this side with respect to y, this side with respect to x. So you have dy is equal to 2 dx, and you have dy dx is equal to 2, where the change in y equals 2, change in x equals 1, and that is the same as y equals 2x. So I'm just proving that these derivation formulas are consistent with a graph where the change in y divided by the change in x is equal to the slope, which is the derivative, right? So the change in y is up this way, the change in x is over this way. So the change in y divided by the change in x, in this case, is 1. So dy dx, I'll do it again, equals 1. So if you multiply, you have dy equals 1 dx. And the line is y equals x. So if you want to go the integral, you integrate, is the opposite of a derivative, you get to here. So if you have y equals x, you want to know what the rate of change is. What you do is you take the derivative here with respect to x. And what you get is and then the derivative of x with respect to x, dx over dx is just 1. So what you're doing is you're multiplying both sides over d dx. And if you put an x up here, this just goes to 1. So you have dy dx is equal to 1. So that proves that the derivation formula works. dy dx is equal to 1, dy dx is the slope, dy dx is equal to 1. So if you want y equals x, the derivative is dy dx is equal to 1. So you follow along this trend, you have integral and you have derivative. If you do all of this in the same way that I just proved with like just looking at the graph, the integral of x is x squared over 2. The derivative of x squared is 2x. And this trend is